Okay, so I'm going to go over glycolysis. And glycolysis is going to start with a 6-carbon sugar, usually. So we've got glucose here, right? And we know that that glucose is going to be split into 2 pyruvates eventually, and we're going to have a net of 2 ATP and 2 electron carriers of NADH plus H plus. So here's the steps. One of the first things that's going to happen is this energy investment phase where that glucose is going to be phosphorylated, okay? So here's my 6-carbon sugar, and then an ATP is going to come in. So this is energy investment, ATP, and it's going to bring a phosphate, right? And then ADP is a byproduct. And that happens 2 times, right? So we're going to get that happening again. So another ATP comes in, and we also get ADP as a byproduct, okay? This is called phosphorylation. And essentially what has happened is we've added some energy to this glucose molecule, okay? So now the glucose molecule is the 6 carbons, but it has these 2 phosphates added to the end. That's giving it enough energy that it will allow it to then split, okay? And the splitting has a name. This is called lysis. Okay, so now we have 2 3-carbon sugars with an additional phosphate on each side. This is our energy investment phase. Okay, now we're going to get the energy payoff. So a couple things are going to happen to this 3-carbon molecule. Okay, so one thing that's going to happen is, so here's our 3-carbon molecule. And one thing that's going to happen is an electron carrier is going to come and oxidize, right? So we're going to get an NAD+, and that is going to oxidize the 3-carbon sugar, and we're going to get NADH plus H plus, because remember, oxidation is losing, right? So that happens to both of these guys. So here's our NAD plus, goes to NADH plus H plus. Essentially what's happening here is this NAD is stealing an electron from this 3-carbon, all right? And so this NADH plus H plus and this NADH plus H plus on each of these, that's going to be the one of the resulting products, right? All right. And then another thing that's going to happen is we're going to get the inorganic addition of phosphates. So inorganic phosphates are added. There's an enzyme that helps with this. You don't need to know it. Right? So that's going to be added to each. And this, as I said, is oxidation, right? And this oxidation and this oxidation, these are our electron carriers. These are going to be really important later on during oxidative phosphorylation. Okay, so the energy that these guys have right now will go on to drive a whole bunch of ATP creation. All right, so then now what we're going to have is ATP synthesis is this next part. So here's our 2 3-carbon guys, right? And each of these have the phosphates, right? And we're going to get an ADP. This is called substrate level phosphorylation. So what happens here is an ADP, so 2-diphosphate, is going to steal this phosphate from the 3-carbon sugar, and it will make ATP. And this happens 4 times. So these 2 are going to come together to make ATP here. This happens ADP plus the P is going to make ATP, and then ADP, plus this, right? to make ATP. Okay, so look at that, 4 ATPs, right? And now, since we have done ATP synthesis, what we have left are 2 pyruvates, right? So our net production here, we have two total NADH plus H plus. We use 2 ATPs here, but we gained 4, so we actually have a net 2 of ATP, and we get 2 pyruvates. So what goes into it is glucose, right? And what we get out are 2 pyruvates, we get 2 ATPs and 2 NADH plus H pluses. Of course, you know, we do need to add, there's all these reactions going on. So ADPs have to go in, NADH or NAD pluses have to go in. But overall, it's important. You've got the energy investment phase and your energy payoff phase, right? So this is energy payoff. And what we get out of glycolysis is 2 electron carriers, NADH plus H plus, 2 ATPs, and 2 pyruvate.